In this lesson video, we'll be talking about structs and how we can add functions to them. So, in Java, we're able to write classes, and then inside those classes, we have instance methods, right? Well, in Rust, we can accomplish the same thing with structs. And so for the rest of this lesson, I'll be using this rectangle struct to sort of get my point across. And so as you can see here, we have a width and a height for that rectangle, and we're going to use those two values, which are 32-bit unsigned integers. So now we have some new code here. And as you can see, under the second part of this code, we have an area function that's getting the width and the height of the rectangle and then returning the area of it, which is just them being multiplied. So there are a couple new pieces of syntax here. First off, we have the IMPL, which is short for implement. And so we're using IMPL to tell Rust we're implementing in the context of the rectangle struct. And so this block where we have the area function inside of is only going to be able to be used with the rectangle. Now inside here we also have that and self that I mentioned. And so the first argument of every method function in Rust that wants to be able to use self needs to be and self, right? You can't say take in a new width then self, right? It needs to be self first and then any other arguments you have after that. Now you can also use and mute self if you want to be able to change the values in self. Let's say we wanted to have a setter for a new width. Now, once we have that code, we can now take a look at how we use these functions, right? So for example here, we have a rectangle and then we're passing it into this print line function and we are saying give the print line the rectangle's area. And so you can see here we have this dot notation which allows us to just directly call from the struct rather than having to do area and rectangle1, right? Because that wouldn't make very much sense. It would be kind of annoying to have to write out when instead we can call it as a separate function. So, some side notes on method functions. First off, implementation blocks can have multiple functions declared inside of them, right? You can declare more than just area inside of it. However, you can also have multiple implementation blocks for one struct, right? You don't have to put it all inside of the same implementation block. You can also, as I mentioned earlier, have more than just and self arguments, right? You could say do set new width and then inside of there take in self just like before, but then have a new width as well. And then you could set the self's new width. And then finally, method functions can also not take and self as well. And so these functions are a little bit unique because they are going to be operating as if they were static functions in Java, right? They don't actually have a function that or a struct that they will be working with. Instead, they'll be just directly working as if they were from a static context. So now I'm going to go into an example that shows off all these different things about structs as well as the stuff that we talked about last week and sort of hopefully gets you a little bit more comfortable with using structs in Rust. Alright, so for this example, we'll be tracking birthdays. As we go through a bunch of different structs, we're going to have a person struct that will show us how we can sort of store all this data and then change these birthdays as we go. So we're going to start off by declaring our structs, right? So we have two structs. We're going to start off with the person struct, right? And in here, we're going to store a name with a string, and then an age, which will be a U8. And then a birthday, which the type we'll get to in a minute. So one thing to notice here is that the string and the U8 are values that I've chosen for a reason, right? The string is just because obviously it's a string. However, with an age, the reason I'm choosing U8 is because the age of a person, at least as far as I'm aware, has never gone above 255. So why waste extra bytes that we can save by just using a U8 instead? Now, theoretically, we could also probably go down to like a U4, given it would be like 128, but even now, I'm pretty sure that it's just easy enough to use the U8, but that's just something to consider if this were a extremely large project. Now, I mentioned this birthday struct, or this birthday value, and so what we're going to do here is we're going to use a separate struct, and in this case, we're going to implement our own custom date version of a struct. Now we could use a library for this, that's totally an option, or a crate for this, but we're going to do this by hand just so that we get some more practice with structs. So inside this custom date, and I'm also going to change this up here to be a custom date, inside of it what we need is a month, which will also be a U8 because there are no more than 12 months in a year, and same thing for day will be U8 because there are 30 days in a year. Now, the compiler is going to complain that we haven't actually used any of these structs, which we will in a minute. Now, we have these values, but we actually need to do something with them, right? So let's start off by creating a function called equal for custom date. And what this is going to do is it's going to check if two dates are equal. So as I mentioned in the lecture, we're going to do an implementation block, and inside here, don't forget to put the name up here, you're going to be putting a function. In this case, we'll do equal. And inside here, we're going to take in a reference to self, and then another custom date, which will be a reference to that custom date, or a borrowed custom date. And then we'll return a bool, right? And so one thing to notice here is that while we're doing this, we are borrowing these, but they are not mutable, right? And so we don't have to do anything changing them, we're just reading them. Now, for now, I'm just going to put return false just so that the Rust compiler doesn't complain to me. And now let's talk about what we want in here. So for this custom date, in order for them to be equal, all we're going to do is check if the two dates are the same. So we're going to first check if self.month is equal to other.month, and if self.day is equal to other.day. And that's all we have to do, and then we can remove that return line, and we now have an equals function, right? And so this will tell us whether or not a custom date is equal. Now, in theory, we could have probably just done something else to do this. I'm pretty sure even Rust will just by default let us do equals equals on this struct because it's two primitive types, but this is for practice. This is obviously something that you might want to look into optimizing in the future. Now that we have this function, let's talk about our person now. So this little project is going to keep track of a bunch of people, and then it's going to go through a bunch of days of the year and keep track of people's ages as we go through those days of the year. And once we reach someone's age, we change their age by 1 and continue going on in the loop. And we do that until a certain amount of time has passed. So how we're going to do that is we're going to create a function that helps us age up a person if they are of the correct birthday. So we're going to have an implementation block for a person now. And inside of here, we are going to have the function try birthday. And what it's going to take is a mutable reference to self, because remember, it's going to be changing the age based on the birthday. And then we are going to do current date and custom date. And then we are not going to return anything. And this function will just work or it won't. So now inside of this function, we are going to do one thing, which is we're going to check if self.birthday is equal using that dot operator. And as you can see, Rust in VS Code was very smart and was able to tell us exactly what we need. And so inside here, we need another custom date. Well, we have the current date, right? And so if these two are equal, then we want to change the age by 1. And that's where we're going to be using that mutable reference to self as opposed to just the normal borrowed self. And then in this case, we are also going to print out a little thing that just says the person's name is now however many years old, right? And so now in here, we are going to have self.name and self.age. Okay, perfect. Now, one thing to keep in mind is if you wanted to optimize this code, you would not be putting print lines in here because as you start to run more and more of these functions, you're going to be slowing it down. So ideally, you shouldn't have side effects like this print line here, but it should be instead handled by the upper level code, maybe checking whether self.age changed. But in this case, since it's a simple project, we're just going to keep going with it. So now that we have sort of our person and our equals as well as the date all implemented, we're now going to work on a main function that will show us exactly how we need to do this. So for this main function, we're going to define some people. So in this case, I'm going to remove the print line and we're going to say let a mutable array of people be equal to, and for now we're going to just declare one person and we'll do more as we go. And so in here we're going to do a name, which will be a string from the lowercase str type, and that will be a person named Madeline Wood. Next up, we will have an age of 5 and a birthday, which will be a custom date. And inside here, we will have a month of 0 and a day of 0. So this will mean January 1st. So now we have this first person who is 5 years old and has a birthday of January 1st. Now, we have this person, but we also have to consider the fact that this person is also going to have this birthday, which is a struct inside of the struct. And you have to keep in mind that this person is the owner of this custom date struct, and so you can have recursive structs inside of each other. So now that we have that, we're now going to move on to actually doing stuff with this person, right? So now we're going to write a quick little loop, and so in here we're going to do for a month in a year from 0 to 12. Then for each day in that month, and in this simplified version of a birthday calculator, we are just going to pretend months are all 30 days. Inside there, we're going to let the date equal a custom date where the month is the month and the day is the day. I know, crazy idea. So now that we have this day, we're going to say for every person in here, we're going to use I notation because we actually want to be able to modify the people in the array. If we didn't want to, we could just use the iterator, which I'll show off in a minute. So now inside here, what we're going to do is we're going to have people I, and then we're going to try birthday. And inside here, we're going to pass in the current date. And so now what this is going to do is it's going to pass in a mutable reference to people I. And the reason it's able to do that is because we have this mutable reference to the array. And it will then pass it in. It will try to change the birthday or change the age if it is their birthday, and then it will exit. So now that we have this code, let's go through and print all of the birthday or all of the final ages out. So inside here, we're going to put final ages. And now out here, we're just going to do for person in people. And we're going to call the iterator. And so what this is going to do is it's going to give us every person individually automatically, and it looks super clean compared to having to do I notation like above on line 46. So now inside of here, we're going to do print line, exclamation mark, and then inside here, we're going to say person's name ended at age, and then whatever their age is. And so now we'll do person.name, and we'll do person.age. And so now, as you can see here, we have this little for loop that's going to give everyone's names and their age. So if we try and run this right now, you'll see that it will say Madeline Wood is 6 years old, and they ended at 6 years old. So that's correct. Now, we can also run this with more people or more years. So we're going to start off by adding more years. So we're going to do for year in, and in this case, we'll go from 0 to 3. We'll do 3 years, and we'll keep all the code from before. And so this, we could also just put underscore here to let us know that we're not using the year, we're just reading that value as a way to have a bigger for loop. And then finally, I'm going to add some more people in here so that we can see how this looks at scale. So I pre-prepared all of these people, so you can see we have 4 more people, all different ages and birthdays. And so if we run this now, you'll see that all kinds of different people have different birthdays throughout the year, and then their ages are finally printed down here. And so as you can see, we ran this for 3 years. And so Madeline, who started at 5, is now 8, and so on with everyone else. So yeah, that is a quick little example with structs. I hope you sort of followed along with that. If you have any questions, please feel free to message me in the Discord in lesson questions or post on the forum. And yeah, I will see you in the next video.